First problem on this worksheet, we are going to be writing the formula of the compound that is formed after each one of these acids donates its H+. The definition of an acid is that it's a molecule that will donate an H+ in an acid-base reaction, and being able to write the formulas of these acids after they've donated their H+, this is going to be kind of the first step in helping us predict the products of acid-base reactions. This is actually a pretty simple process. What we want to do is remove one of the hydrogen atoms from the molecule because it's donating one of the hydrogen atoms, and then we also want to remove a positive charge from the molecule, and that's kind of the trickiest part. So when we look at this first problem here, we have HCl, so we want to remove the hydrogen from the molecule. That's going to leave us with just a chlorine. And then we also want to remove a positive charge. So if we kind of think about this like a math problem, HCl has a charge of 0, it's neutral. And then we're going to be subtracting from that a positive charge, which is kind of funny math, the way that I've written it there. Basically 0 minus a positive 1 charge. That's going to leave us with a negative charge overall. Here's our next example. We want to remove the hydrogen. That leaves us with NO3, and we want to reduce the charge. We want to remove a positive charge. So that's going to take us down to a negative charge. Here's HCO3 minus, remove that hydrogen, and then we also want to remove a positive charge. So for this one's a little bit different. We're starting with a -1 charge, and we want to subtract from that a +1. We want to subtract that +1. Again, that looks really goofy. -1 minus 1. That's going to leave us with a 2- charge. Here's H2SO4. When there are 2 hydrogen atoms in the formula, we're only going to be donating 1 of those hydrogen atoms. So we have 2 hydrogen atoms. We're going to take that down to 1 hydrogen atom, HSO4. Neutral molecule, removing a charge. That's going to take us to a -1. And then last but not least, look at, we've got so many hydrogens in this molecule, but we're only going to be removing 1 at a time. When you have 4 hydrogen atoms in a molecule to remove, you really could choose to eliminate whichever one you wanted. So you could turn this subscript into a 2, or you could get rid of this one. Typically, when we have multiple hydrogen atoms in the molecule and one of them is off all by itself, like it's not being clustered with the others, that's a hint that that's the one, like traditionally when we're writing the formula, that's going to be the hydrogen that we leave off. And then we're going to take that charge down to a -1. So now we're going to do the opposite thing. We've got this list of bases, and we're going to write the formula of the molecule that's formed after each one of these bases accepts an H+. So again, we're doing the opposite thing. We're going to be increasing the number of hydrogen atoms by 1. So if we're starting with 1 hydrogen atom, that means we're going to take it up to 2 hydrogen atoms, and we are adding a positive charge. So we've got right now in this example here, we have a -1 charge in the molecule, and then we're going to be adding a +1 charge. So this thing is going to end up neutral. Here's another example. We want to add a hydrogen, and it's pretty conventional that the hydrogen is going to be the first thing that we write in the molecular formula. So we'll put that first, HBr. Again, we have a negative charge, and we're going to be adding 1 to that negative charge, so it takes us to a neutral molecule. Here's HPO4 2-. Let's put that hydrogen with the other one, so it's H2PO4. We have a 2- charge, a -2, and we're going to be adding 1 to that. That's going to take us up to a -1 charge. ClO4-, there are no hydrogens, and conventionally we're just going to put the hydrogen at the beginning of the formula, HClO4. Negative charge, when we add positive to that, it's going to make a neutral molecule. And then last but not least, NH2-. Let's put that hydrogen with the others, so we have NH3. We're starting with a neutral molecule. When we add our +1 charge to that, we're going to end up with, we're starting with a negatively charged molecule, adding a +1 charge, ending with a neutral molecule. So now that we've practiced this, what we're going to do is work on predicting the products of acid-base reactions. So at this point in chemistry, you are not really expected to know which is the acid and which is the base. So to try to keep things simple here, I've just told you that the first compound is always going to be the acid. So that means that this guy is going to be the acid and this is going to be the base. And that's the pattern that I'm using on this worksheet. But that is not standard notation in chemistry. When you're looking at an acid-base reaction, there is no rule and there's not even any general trend. So don't expect the acid to always come first and the base to always come second. You should always know somebody should communicate to you which is the acid and which is the base. So when we're doing this reaction, when we're predicting the products of this reaction, we're basically going to do what we just did in the first two problems on this worksheet. We know that we have an acid, and the acid, I'll just kind of make a reminder here, the acid is something that is going to donate or lose the H+, and then the base is something that is going to accept or gain the H+. So in this reaction, the molecule that's the acid is going to lose its H+. From HBr, it's going to become Br-. And then the molecule that is the base, that is going to gain an H+. So instead of OH-, I'm going to write it kind of funny at first. It's going to be OH2, but that's water, and we typically write that as H2O. One way that you can double check that you've done this correctly, obviously it should be balanced as you go through, and you should also see a balance in the charges. So if you add up the total charge on the left-hand side, that should also be adding up to the total charge on the right-hand side. Here's our next example. H2O is the acid in this reaction, so that means we're going to be losing one of those hydrogens, and we're taking it down to a -1 charge. NH2 is the base. That means we're going to be increasing the number of hydrogens from 2 to 3, and we're increasing the negative charge to neutral. And again, if you got a little bit lost there, how do I know this is the acid? How do I know this is the base? That's just because what the problem is telling us. The first compound is the acid and the second compound is the base. So for our next one, we have H2CO3. We're going to decrease the number of hydrogen atoms from 2 down to 1. We're also going to take away a positive charge. And then for NH3, we're going to, because that's the base, we're going to increase the number of hydrogens from 3 to 4, and we'll be adding a positive charge to the base. For our next one, our acid, HNO3, we're going to lose that hydrogen, and we're going to lose a negative charge, so that becomes NO3-, and then CH3COO-, we're going to add a hydrogen to that molecule. This molecule's just got kind of a unique way of how we communicate or how we write its formula. We typically write that hydrogen at the end. You saw that molecule on this worksheet. And we've got two more. NH4+, as an acid, we're going to get rid of one of the hydrogens, and we're going to take that charge down. Starting at a +1, we're going to subtract 1. That's going to leave us with a neutral molecule. HPO4-, so we're going to add a hydrogen to that molecule, so it's going to be H2PO4. We're also adding a positive charge. And then last but not least, so this one's kind of tricky. We have H+, our acid, and we're going to be removing H+ from that acid, which means there's going to be nothing at all, nothing. And then we have our base, which is OH-, and we're going to be adding a hydrogen to that guy and also adding a positive charge. So we're going to have a negative charge, and then we want to add a positive charge to that. That's neutral. OH2, which is a funny way of writing H2O. So this one looks kind of goofy because we're typically in an acid-base reaction, we're ending with 2 products. But in this particular one, we end with just one product.